Okay, so we're going to do 9.2 today. It has to do with radian measure. So it's a new angle measure, so it's kind of interesting, new idea. So let's take a look at this. Very fascinating stuff. Okay, so define general angles and use radian measure. I remember hearing that, you almost think it's like Martian or something like outer space with a radian gun or something. I don't know. Anyhow, we're going to find out about this. So our objective today, students will be able to explain how the unit circle in a coordinate plane enables the extension of the trigonometric functions to all real numbers, interpreted as a radian measure of angles traverse counterclockwise around the unit circle. Actually, I'm going to show you this mainly in this lesson, and hopefully it'll make more sense. And fascinating. Okay, so then our essential question is, well, what exactly is a radian measure? So far, we've only dealt with degrees, and you guys know that a full circle is 360 degrees. Well, it turns out in trigonometry, we often like to use another angle measure unit that we use, and in this case, it's called the radian. And so we're going to find out about that. So let's look at this. At first here, we're going to learn a little bit about about angles and terminal side and initial side and so on and so forth, standard position. The main thing to take from this slide here is that an angle has two rays, of course, and when we set things up on the coordinate plane like this, the initial side is always taken right here, like on the x-axis. This is the positive x-axis, and so the initial side is always the positive x-axis, and it represents 0 degrees. And if you were to do a full circle counterclockwise 360 degrees, you'd be right back smack at the beginning point. And so 360 degrees is basically the same thing as 0 degrees. In fact, later on we'll say that these two angles are coterminal. It means they end at the same spot. Well, more about that later. Anyhow, so we then rotate this kind of like a minute hand moving around a clock. You've seen that all before. But this clock goes counterclockwise. For whatever reason, people that created trigonometry and angles and stuff like that, they've always decided to measure angles going counterclockwise. It's kind of backwards from our watch and things like that. Anyhow, so we sweep out an angle kind of like this, and wherever we stop is the terminal side. Basically, this is where it ends. And so that should all make sense. And so what we say is that an angle is in standard position if its initial side is at the origin and it lies on the x-axis. So, I mean, you might have an angle here, and it might measure, 30 degrees, from geometry. Well, this isn't in standard position, but if we rotated this side down to here, like that, where you would have this side matching up right here, and then this side rotated over to here so that you have a 30-degree angle here, now we would say that that angle is in standard position. Okay, I know that looks all messy. But anyhow, that's pretty much all we need to do with this slide. Just read it over and just kind of look at this a little bit. And let's try an example now. So look at the next slide. So let's try these real quick. Practice. Okay, draw an angle with a given measure in standard position. Well, that pretty much means then what I'm going to do is I'm going to always start off by drawing like a coordinate plane. And imagine that the angle always starts off in this position here. This is the initial position. Okay, and we kind of sweep around this way and we keep going until we get to the number of degrees that we're after. Now you need to realize, you should know this already, a full circle is 360 degrees. So that means a half circle is 180 degrees, and a quarter circle is 90 degrees. And if you went 3/4 of a circle, you'd be 270 degrees. And if you went around a full circle, that'd be 360 degrees. At which point you're at the same starting point, 0 degrees. Started off at 0 degrees. Well, so in this particular problem, we're just supposed to show an angle in its standard position. That means one of the rays has to line up with the x-axis here. And it's about 90 degrees. 135 degrees would be, somewhere like that. Maybe like that. Right down the middle. So this side would be the initial side. Initial side. Okay. And this would be the terminal side. Okay. Anyhow, there's an angle. Bam. Well, this one's a little bit more tricky. Let's start out again by drawing a coordinate plane like this. And one of the things you need to realize is that angles and trigonometric functions are like cyclical. I guess that's the right way to say it. They go around in circles, basically. So you know that 360 degrees is a full circle, right? So if I were to go 640 degrees counterclockwise, well, part of this 640 would be used on the first rotation around. It's almost like the clock went around once and it's back to its starting point. And by going back to its starting point, I've done one complete rotation around like this. And to that spot there, I would have used up 360 degrees. Well, the question is, how many degrees are left? Well, just basically take this number and subtract. Let's see, 640. If I were to subtract this, and get a 0 here, 80 there, cancel that, that's a 5, right? And I have about 280 degrees to go. So what I do is I just keep going. There's another 90, there's another 180, there's 270, and I need to go 10 degrees more. So that means my terminal spot is right here. So here's how we would write this. Now normally you don't draw this dumb circle junk. So let me back this off real quick. Bam, 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 bam. I'll back this off a little bit. Okay, so what we found out is that the initial side would be right here. And we go around one full time, that'd be 360, and we need to go 280 more. So the terminal side would be, well, hold on, not quite that bad. Terminal side would be about 10 degrees more. So there it would be. This 640 degrees would be to here. Of course, it would have gone around once before it got there. And that's kind of how we draw this. Okay. Hopefully that makes sense. This one, now a negative, when we put a negative in front, it just means we go the opposite direction. So in this case, we'd start out with, we have our coordinate plane, and we start going around the opposite direction. So this would be negative 90 degrees, this would be negative 180, this would be negative 270, and this would be negative 360, which would coincide with 0 again. So it just means we're sweeping around this way. So 105 degrees would be this angle to right about there. It would be our terminal side like that. And so this would be our initial side. The initial side still starts off with the x-axis, positive x-axis, and sweeps around to right there. Okay, so hopefully that makes sense. And you're going to have a few little problems where you're doing the initial side, the terminal side, and then there's this idea called coterminal angles. Let's read about that. I kind of alluded to it earlier already. It's where two angles coincide to be the same spot, like 0 and 360 degrees. When you go a full circle all the way around, there's an angle here. It starts off at 0 degrees. If you had a 0 degree angle, in this case a 0 degree angle, the initial side and its terminal side would be right smack on top of each other. It's like it hasn't moved at all around the clock, clockwise, counterclockwise. So that'd be 0 degrees. But if we swept this around, all the way around, we went back over to here, we'd be right smack on top of 0 again. And so we would say 0 degrees and 360 degrees, we would say they are coterminal. Means they end up at the same spot. Does that sort of make sense? So looking at these problems here are pretty easy. Almost think you could do it all on your own. But let's erase this and start over. And I'll at least help you out with part A. And then I'll want you to do part B on your own, okay? So, let's take a look. We want to find an angle that is coterminal. We want one positive and one negative one. Okay, so negative 45 degrees, first of all, would be right here. If we swept this way, this spot right here would be negative 45 degrees. So what we want is an angle to end up there. One of the ways we want to go is the positive direction though. We want the positive one and we want a negative one. So going the positive direction, I'll just use a different color here. How about purple? Okay, so going the positive direction, we go here, we go here, we go here. Now, this is almost a full circle. In fact, remember 360 degrees is a full circle, and that's kind of a hideous color, so let me use a different color. Let me use this pink color. That's 360 degrees. And so we've gone around basically a full circle this way, and we're almost a full circle. In fact, we're only 45 degrees short of that. Well, if a full circle is 360, if we subtract off 45 degrees, we will have the measure of this angle going this way. Okay, and that will be our positive angle. Okay, so 360, I think that gives me 315 degrees. So the positive angle that's coterminal with negative 45 degrees is 315 degrees. Okay, there's our positive answer. Positive, no, that's ugly. Okay, anyhow, we need to do a negative one that ends up at the same spot though. Well, remember, going in the negative direction, we have to continue going this way. So what we do is we just go one full circle around and we'll come back to here again. Well, remember, if we do a full circle is just adding another 360 degrees. But it's going in the negative direction. So you have negative 45 degrees. You add on another negative 360 degrees. And where does that take you? It takes you to 405, I think. Is that right? Negative 405. You see? So a coterminal angle that's negative, remember it would normally start right here. So it does a full circle that gives you 360. Another 45 takes you to negative 405. So there's our coterminal angle with this original 45 degree angle. So we have the positive one, we have the negative one. So that's what you're doing when you're doing these coterminal ones. Now, as far as your study guide goes, remember you're doing this PowerPoint. I want you to do part B on your own. Okay, so go ahead and do that on your own. I'll give you some time here, maybe 2 minutes. Shouldn't take you too long to do that. You want to start out by, whoops, can't see that, can you? Okay, start out by drawing this. And this time, find your original starting point, and then just go 360 degrees more and come back to the same spot. Or go the other direction by going negative 360 degrees. So, and I'll do part B on your own. I think you can do that. Okay, well, let's keep moving along here. What do we got here? Oh, we're going to get into the idea of what a radian is. Okay, so it turns out that it's advantageous for us to define an angle based on the number line. So I want you to imagine a number line right here. It's a really long number line. And I want you to imagine we're like at the origin here. And I want you to imagine also that we have a circle. And so we have this circle with a radius of 1. Now this radius is 1. So that's 1, and this is 2, and this is 3. This is my number line now. 4, and then 5, and then keep going here, and this 6, so on and so forth. And so now I have the circle that's a unit circle that I'm going to place right here. I want you to imagine that this is a circle. Okay, and so there you have it, like that. Okay, so now here's what you have to imagine. Well, first of all, let's find the circumference around the circle. You guys know from geometry that the circumference is equal to 2 pi r. Well, in this case, the radius is 1, so circumference is equal to 2 pi times 1. So the distance going around this circle is exactly equal to 2 pi. Now, if you multiply this out in your calculator, remember pi is 3.14, so this is equal to 2 times 3.14. If you multiply that out, okay, do it like this, you get approximately 6.28, okay? All right, now, you got that idea? Hang on to that idea now. Remember, a full circle is 2 pi, and the total distance around this circle would be 6.28. So now I want you to imagine, just imagine for a moment, that I take our number line and, whoops, okay, all right. Take my number line and I start it right here. So, and now this number line, I'm going to wrap around the circle. So if I were to wrap it around, eventually there would be 1. Keep going, and there would be like 2 would be right about here. And guess what? This spot right here would be about 3.14. You know, all I'm doing is taking this number line and I'm wrapping it around the circle. Why did I know it's 3.14? Well, because I know if I wrap it all the way around, it would be equal to 2 pi. Remember, and 2.2 pi is 6.28. So if I kept going, I'd eventually get to like 4, and then I'd have like 5 somewhere around here. And then this part of the number line would be exactly right about there, would be 6.28. Does that sort of make sense? And so if we wanted to, we could take this number line and continue to wrap it around this unit circle. Now remember, this unit circle has a radius of 1. And so we just found out the circumference. So every time you go around the circle, you go 6.28 on the number line. And 6.28 would be right about here. Does that sort of make sense? That's the basic idea of what a radian is. And so instead of using degrees to measure angles, we're going to actually use radians. And it's related to the circumference of a circle with radius 1. So that's what we mean by consider the following. If you didn't get that, please rewind it and listen to it one more time. Anyhow, so if you kept going around the circle, this would be 6.28. Eventually you get to 7, and then you get to 8, and then you get to 9 somewhere over here. You know, you just keep going around. By the time you went around again, this would be about 12.48 or so if I double that. Yeah, it'd be 50 something, 56. You see? You take your number line and you wrap it around. Okay, now let's go back and read about it. Okay, so by the way, let me just back up a little bit. as far as your slide goes, and remember you're going to turn that in, I want you to copy that diagram that I made. You know, I started out with a number line. Whoops. You know, copy the diagram I made real quick, starting like this. I made a circle going around, and I had a number line here. That's what you want for this slide here. So when my wife grades your papers, or when I grade them, that's what I'm looking for, okay? Okay, so anyhow, let's continue. Okay, now let's just read this here carefully together. Okay, so what exactly is a radian? All right, you ready? Angles can be also measured in radians instead of degrees. To define a radian, consider a circle with radius r centered at the origin. That's what I did here. 1 radian is the measure of an angle in standard position whose terminal side intercepts the arc at length r. Okay, so now they're saying if the radius is equal to 1, okay, then this distance here is 1. You see? And so this is how you put your number line on there. This would be 1. Remember, if you kept going, 2 would be right around here or so. And then this would be right about there, would be exactly 3.14 because it's pi. Remember, you do 2 pi for a whole circle. Anyhow, 1 radian is this angle measure up to this point here. So 1 radian. It's where this length is exactly equal to 1. Now you might wonder, well, how many degrees is that? Well, there's a nice way to convert from radians into degrees. You know that a full circle is 360 degrees and a half circle is 180 degrees. So this is 180 degrees. This spot is also 3.14 radians. Okay? So just think of it as a number line. And so here's a little conversion. We have a little conversion right here. 180 degrees is equal to pi radians. Okay? You see, this location would be pi. This location here, if we did a full circle all the way around, would be 2 pi. Okay? This, of course, would be pi halves. You see? So you do half pi, a full pi. This spot right here would be 3/4 pi. Okay? But when we're using this radian, this pi stuff, we put on this word here, radian. Now we always abbreviate, so when we're dealing with radians, we just use the first 3 letters, and we would say that this angle measure to this spot here would be 3/4 pi radians. Fascinating. Okay, so this will be a little bit confusing until we do some practice problems. Now here's a conversion factor that'll help you remember. It turns out then that this angle measure right here, 1 radian, is about 72 degrees if I remember correctly. And we'll see how to do that later on. Anyhow, let's do a couple examples. Right here. Okay, so to convert to radians or degrees, you can use this here. You're either going to multiply by 180 degrees or you're going to divide by 180 degrees. I'm going to do some examples here in just a moment. But use this as some notes for you. I mean, when you're doing your assignment, until you get it figured out, it's pretty easy for me. If you took geometry, this part should be easy, okay? Don't fear, it's pretty easy stuff. It's just related to circumference. Okay, so let's take a look at a problem now. So we're going to practice changing from degrees to radians, and then also from radians to degrees, back and forth. We got to be able to do this really good. So if I start off with 75 degrees and I want radians, okay, what do? Well, I need to use the fact that 180 degrees is actually equal to pi radians. Okay, so I'm going to abbreviate it like that, pi radians. Okay. So what I do is I multiply by a conversion factor. I want the degrees to cancel out. So I'm going to put 180 degrees right here. 180 degrees. You see what happens then is that the degree cancels this one. You see? And so then up here I want 1 pi radian. You see? So the way you do this is you just take 75 and divide by 180. And what we end up with in this case, I'll do it here, 75. You see, what does this equal? Some people get confused here. Let me put my eraser here. This is equal to 75 times 1 pi radian, okay, divided by 180. Well, to do this, if you want, you can do this part in your calculator, okay? So 75 divided by 180. 75 divided by 180 is equal to, okay, so what that is equal to, it's 0.41666 repeating. Now, to get it completely in radians, you just multiply by 3.14. You see? And so, because that's what we're going to use for pi, right? Or you can just use your pi button on your calculator. So times pi. So anyhow, what this is equal to is 1.3. Let's see. I'm going to round off here. 309 radians. Okay, so there you have it. That's how you do these conversions. Bam. Pretty easy, right? So let me just give you a picture of this real quick. If we were doing this, 75 degrees, a 75 degree, remember a 90 degree angle would be right here, right? And, well, pi is equal to 3.14, right? 3.14. And if you take pi divided by 2, okay, so take the number pi, 3.14, and divide it by 2, then this spot right here that matches up with 90 degrees would be 1.57 radians, okay? Okay? And so there's 3.14 radians right here. And so if you were at 75 degrees right here, this is 75 degrees right here, this would correspond to a unit circle that's being wrapped around like that. Remember, you take the number line and you wrap it around, okay? You wrap it around like this. And the number line would be, you know, at some point, 72 degrees is about 1 radian. So this would be about 1. And we found out on our problem that 75 degrees was about 1.309, you see? So it's just beyond 1, just a little bit. 75 degrees would be about that far. And so it's just like a number line being wrapped around. So like 1/2 would be here, 1, 1.5. See, 1.5 is right about here. It's about the same spot as 90 degrees. And then 2 would be right around here. And 2.5 would be right about here. 3 would be right about here. Because 3.14 is a half circle. Does that sort of make sense? Okay, I know it's a little bit confusing at first. Okay, but we did the first one. The first one we found out is 1.309 radians. Okay, Now, suppose we're going from radians back to degrees. Okay, so let's take a look at that. What I start out with is negative 5/4 pi. Now, what I recommend, now some people make this mistake, write in this part here. So you have a radian here, okay? It's radians, okay? Instead of having the little degree symbol, you have a radian. A radian is basically a unitless idea. It's kind of like this degree. It's unitless. It's not like meters or feet or anything like that. But what we'd like to do is cancel out. Okay, I'm going to move this now over to this side. What we want to do is convert here. We want the radians to cancel out. So what we know is that 1 pi radian is equal to 180 degrees. So I'm going to put the 1 pi radian right here, and I'm going to put 180 degrees here. Now look what happens now. The radian cancels, but so does the pi. Isn't that cool? And so now all we need to do is just take this 5/4 and multiply it by 180. Okay, so this becomes negative 5 times 180 divided by 4. And just do that in your calculator. Okay, so 5 times 180 divided by 4. That would be equal to negative 225 degrees. Okay, does that sort of make sense? So you're going to have several problems where you're doing these conversions on your assignment. So you just basically use this idea here, and this is good practice because you're basically doing conversions where you got to cancel out stuff. And if you need to, rewatch the video a few more times if you need to. Anyhow, let's move on. Alright, so one of the things you're going to want to do, especially in pre-calculus, is you want to know the radians and degrees by heart. You want to memorize these. Okay, so what do I mean by that? Okay, so we start out by drawing a big coordinate plane like this. Okay, so let's do the easy ones. Okay, 0 degrees would be right here. 90 degrees would be right here. Okay, 180 degrees would be right here. 270 would be right here. And then 360 would be right here. That would be a full circle. Now for right now, as far as memorizing, we're just going to memorize one full circle. Okay, now what do we mean by pi radians now? Well, this spot would be 1 pi radian. Okay, 1 pi is equal to that. This is radians, okay? So this is radians, okay? Now, halfway would of course be pi halves. So this would be pi halves. Now I'm not always going to write in the radians, okay? But it's understood that there's this radian involved here. Radians. Pi half radians. Okay, so that's pi halves, so that's pi, and then this is another half. So if you added half to pi, you'd have 1.5 pi. Does that make sense? Or that's equal to like 3 halves pi. So that's what this spot is down here. And I'm going to write it right here. 3 halves pi radians. Well, see, we just abbreviate. Okay. Okay, so we have that part so far. These are what we call the quadrant angles because it's like, you know how the x and y axis are divided up in quadrants. 1, 2, quadrant 2, quadrant 3, quadrant 4. So these divide up the quadrants. So these are the quadrant angles. So we know all the quadrant angles now. Okay, so now let's say we split this up. If I go right down the diagonal in degrees, I would have 45 degrees. Okay, if I go this way, I add 45 to 90 and I get 135 degrees. Okay. And if I add 45 degrees to 180, I actually end up with 225 degrees. Excuse me. And if I add 45 degrees to 270, I think that gives us 315 degrees. Okay. So now we've divided this all up into 45 degree increments. 45, 90, 135, 180, and so on and so forth. Well, we need to do the same thing with the radians. Okay. So the radian that's equal to this is pi fourths. And so now you're basically going in pi fourth increments. Pi fourths, pi third, pi halves. The next one would be 3/4 pi, right? 3/4 pi. And then pi, and then 5/4 pi. This would be 5/4 pi. And this would be 6/4, which would be 3/2. And another fourth would be 7/4 pi. And then the next one would be 8/4. Well, but 8/4 pi is equal to 2 pi, right? So that means you did a full circle. All right. Okay, so when we come back to here, we've done one full circle, which would be 360 degrees. And in the radians, if you're doing radians, you'd be at 2 pi radians. Okay. All right, so that took care of the pi fourth increments and the 45 degree increments. Well, the other thing we do are the 30 degree increments. And I think what I'll do for that one, I'll just start the whole dumb thing over again. Let's start off with a new sheet again. And now I'll do the pi thirds and the pi sixths increments, or the 30 degree. So again, this would be 90 degrees. Well, if you split this up into thirds, this would be 30 degrees, and then this one would be 60 degrees. This would be 120 degrees. This would be 150 degrees. And this, of course, would be 180 degrees. The next one would be like 210. And another 30 degrees would be, remember this one's 270. So this one is like 240. We add on another 30 would be at 300 degrees. Finally would be 330 degrees. And finally would be back at 360. And we'd be coterminal at 0 degrees. Okay? Kind of did that fast. So those are all the 30 degree increments. Well, the radians go up by pi 6 each time. So let's take a look at how this one will work. This one would be pi 6. Okay. This one would be another pi 6. So it would be like 2/6 pi. Well, of course, 2/6 is actually equal to 1/3. So this is actually equal to pi thirds. And remember, these are radians. Radians. Sorry about that. Radians. And then this, if you add another third, it'd be 3/6 pi, which is the same thing as pi halves. Okay. Which we did already. If you add another 6 to that, that would be 4/6 pi. And of course, that's equal to 2/3 pi. So this spot right here is 2/3 pi. If you add another 6 to that, we'd be at 5/6 pi. And of course, this would be 6/6 pi radians, which is actually equal to 1. If you add another 6, that'd be 7/6 pi. And you add another 6 to that, would be 8/6 pi. Well, of course, 8/6 pi would be actually equal to 4/3 pi. Okay, so we have to reduce our fraction, so we don't use this one, okay? 4/3 pi. And if you add another 6, you'd be at 9/6, which would be the same thing as 3/2 pi radians. Add another 6, you'd be at 10 over 6. Of course, that's the same thing as 5/3 pi. And you add another 6, you'd be at 11 over 6 pi radians. Again, these are all radians as you go around, okay? And then finally, this would be 12 over 6 pi. And of course, that's equal to 2 pi. Okay, this sounds all rather confusing, but it's something you have to know fairly well. And one of the things you're going to have to know to do the next section that we're going to be going into, 9.3. You're going to have to do all the trig functions, and you're going to have to be using radians instead of degrees. So you're going to have to know this, and so I recommend memorizing this. Now, there's a real handy page in your book that has all of these angles, and I recommend you study that. And I would practice this every day until you get it memorized. So, anyhow, we did that page now. The final idea is this idea here. We can find the area of a certain amount of arc, and we can also find the arc length. The arc length is this portion from here to here. It's part of a circle, so that means it's part of the circumference. Well, remember, circumference is equal to 2 pi r. Okay, but that's for the whole circle all the way around. What if you want to just go part of the way around? Well, that would be arc length. Does that make sense? And to find out the arc length, we just take r and we just multiply the amount of degrees that we've done. Now, hang on just a second. This is always measured in radians. Ooh. So if we use this formula right here, it's very important to know that it's in radians only. You can't use degrees with this one. So if we're asked to do this, we might have to convert to radians first so that we could use this formula. The same is true with this formula here. The angle right here, that's theta, that's measured in radians. So watch out for that. Let's do a problem real quick and we'll demonstrate this. Here's a softball problem. How about that? So what we'd like to know is how much fencing are we going to have to do to put around here. So then we can talk to the school board and tell them how much it's going to cost to put in a new fence. Well, so that means we have to use this formula. S is equal to R times theta. Well, all right. We now know that we know that a half circle would be pi, right? Pi radians. So a quarter circle would be pi halves. Remember, we were just studying that. This part up to here, from here clear up to here, is pi half radians. So theta is equal to pi half radians. Okay, and that's what we have to use when we're using this formula. Okay, so then the arc length is equal to the radius. Well, this is the radius right here in this case. It's equal to 180 feet. 180 feet times theta. Well, in this case, theta is equal to pi halves. Okay, radians. Okay, all right. And since this is in radians, you no longer really need the radians sitting here. The theta just has to be radians instead of degrees. So what you need to do is take 180, multiply it by pi, and then divide by 2. And there you have it. You'll have the answer. So let me do that real quick. 180 times pi divided by 2. That, of course, is just 90 pi. Funny. Okay, 90 pi. And if you want that in decimal, it would be 90 times 3.14.59. It's going to be about 282.74 feet. Okay? All right. So that would give us fencing that goes around the outside. And so we'd probably order about 300 feet of fencing to go around the outside. Get a little bit extra just in case we have to waste some of it. Okay, well the other thing we want to do is figure out how much area this is. Because now you want to put grass on most of it, right? Or you might want to put fertilizer. Well, the formula for area, it said the area is equal to 1/2 r squared times theta, wasn't it? Let me go ahead and look. I don't have this one memorized. So let's back up. What was the formula? Oh, 1/2. Oh, I had it right. So area is equal to 1/2 r squared theta. So now let's go forward again. So if we're doing the area now, area is equal to 1/2 pi. Oh, wait a second. No. 1/2 r squared times theta. Well, we already know that theta is equal to pi halves. Pi halves radians. Okay. So in this case, we're going to get 1/2 times the radius, which is 180 feet. We're going to square that now, and then multiply it by pi halves. And so then now you just put this in your calculator and see what you get. Okay, so 180 squared times pi, and then divided by, well, the 2 times 2 is basically, you're going to have 180 squared divided by 4, and then multiply that by pi. So I'm going to divide by 4 now. So I think we get 8100. Oh, I have pi in here. Times pi. So 8100 times 3.14159. And so that's going to be equal to about 25,446.88 square feet. Remember, areas are always in square units. So that's how much area is here in this sector right here. Okay, so there you have it. Pretty easy stuff. That's the end of my lesson, so I'll stop it right here.